we're going to look at how you can start a single phase AC motor. So if I have the motor and the phase is coming in on this set of stators, the voltage coming in will, let's assume, look something like that, where there's a positive half cycle and there is a negative half cycle. So on the positive half cycle, let's assume current flows in through the windings like such and creates a north pole and a south pole, and the flux lines then will run from north to south. And if I can consider the rotor of the motor just as an electromagnet, so just have it as a magnet here, so we have a north seeking pole being attracted to the north pole and a south seeking pole being attracted to the south pole. That's fine. But when we now switch to the negative half cycle, well, the poles here will reverse. So this will become a south pole and this will become the north pole. So now the south and the north seeking pole here will repel each other, and these will repel each other also. So what the magnet wants to do is that it wants to move down this direction, or indeed move that direction, but it can't. In fact, it doesn't even know which way to go. The force of repulsion in a straight line here and here, so it can't turn. But if you were brave enough and you got your finger and you stuck it into the motor and pushed it, give it a start, the motor would actually turn and would begin to rotate. However, we can't, well, not that we can't do it, we shouldn't do that. We want some method of starting the motor automatically. So how do we do that? Well, what we do is we add in another set of windings and we wire them up with a capacitor in the second set. So if I was to look at the electrical equivalent circuit of that, there is the windings here. Okay, so the windings will have some resistance and they will have an inductance. And similarly on this winding, there will be some resistance in the wires. There will be the inductance, and we have our capacitor here also included. Okay, that's a little bit messy, that drawing, so I'm going to use a proper schematic diagram. Okay, so we have L1 and R1 for the purple windings, let's say, L2, R2 and C for the red windings. So how does that work? Well, let's say the current flowing through L1, okay, so this winding is I1, and let's say the current flowing through this branch here is I2. If I drew a vector diagram, I'm just going to use this acronym here to help me. In a parallel circuit, okay, so this branch is parallel to this branch, the voltage here is common to both branches, that's the reference vector, and the current flowing down through the first inductor, okay, so the first side here, that's purely an inductive. So in a circuit where voltage is the reference, it's an inductive circuit, the current lags the voltage, so the current will be somewhere down there. Okay, I don't know exactly, but let's say somewhere down around here. On the second branch, the current also has to pass through an inductive and resistive and a capacitive load, but let's assume the capacitance is 0 at the moment. Okay, so there it is for the second circuit, and now let's put in a slider here where I can increase the value of the capacitance. As I increase the capacitance, the circuit becomes more capacitive. So in a capacitive circuit, the current leads the voltage. So the current is going to move all the way up here. And we can see that here. So I've increased the capacitor value and the current vector moves. Now if we choose this value correctly, we can create a phase angle between the two currents of 90 degrees. So when I draw that in the sine wave format, there's the two currents, so there's I1 and there's I2. And the phase angle between the two of them is 90 degrees. So what does that mean? Well, if we take at this point in time here, and there's no current flowing through the red winding, so there's no current flowing through here. All the current is flowing through the purple winding, so that'll give us a north pole here and a south pole here, let's assume. At this point here, there is some current flowing through the purple winding and some through the red winding. So I'll have a north pole here, I'll have a north pole here, let's assume. So between the two of them, the vector sum will get the north pole just about there. And at this point in time here, there's no current flowing through the purple winding. Current through the red winding is a max, so the north pole is there. So the north pole has moved from there to there to there. We have a rotating magnetic field, and you can look at my video on that. But if we have the rotating magnetic field, then the magnet, or the rotor, which is essentially a magnet, is going to follow that. So it will start to turn. And that's how you start a single phase motor. On some of the motors, once the rotor is rotating at a particular speed, a centrifugal switch will open and cut this branch out. We won't no longer need to have it, and we call that a capacitor start. And on some of them, there is no switch. The capacitor is in for the whole time the motor's on, so we call that a capacitive start and run. So I hope that explains how you start a single phase AC motor.